Welcome to section 2.3, and we are now ready to begin this particular section. This section deals with circles, and in particular circles in their standard form. And number one begins with, what if the radius is 4 and the center is 1, 0? What is the standard form of the equation of the circle? Well, how we do this is we first put x minus the x-coordinate of the center and square that whole thing, plus then we do y minus the y-coordinate and square that, and then finally what we do is we take the radius and square that, and then all we have to do is to simplify this a little bit further. First of all, this one's not going to simplify for standard form at least, but y minus 0 is y, so we can simplify that to that, and 4 squared is 16. And so this is the answer to number 1. X minus 1, the quantity squared, plus y squared equals 16. Now working in reverse, if we are given an equation in standard form, we need to be able to find the radius and the center. Well, the center is simply this, x minus whatever goes here. Well, that would be negative 10. X minus the negative 10 turns into x plus 10. And y doesn't have anything going on, so that has a 0 value. Now the radius here would be the square root of that right-hand side, which is equal to 2. So the center is negative 10, 0, and the radius is 2. Now with that in mind, realize that if we have an equation given in standard form, it's relatively easy to graph the circle. So let's suppose the radius is 4 and the center is 2, 0. And we are asked to graph this. Well, the first thing we want to do is to find the center. And that's right there, 2, 0. Now if the radius is 4, that means it's going to go 4 up, 4 this way, 4 this way, and 4 this way. So let's just try and draw in those values. And due to the fact that my graph is quite off, my circle may not look all that well. Plus, it's very difficult to draw a circle on the computer here. But what I'm going to attempt to do is to draw these quarter parts of circles, and it's not going to look very good at all, in fact. But as long as you have these points very well marked, I will know that that was the intent. This is intended to be a circle. So much for my try. Example number 4 gives us the equation, and we are asked to graph it. And the equation is x squared plus y minus 3 quantity squared equals 36. Okay, I see the center. The x-coordinate is 0 because nothing's going on with the x, and the y-coordinate is a positive 3 because it's always y minus the y-coordinate. So the center is 0, 3, and the radius is the square root of 36, which equals 6. And so to graph this, I'm going to be at the point 0, 3. That's my center. Then I'm going to go 6 above that. Six below that. 6 to the right. And 6 to the left. And that's always from the center. It's not from the origin. Then once again, I'm going to attempt to draw quarter circles between each of these. More successful in different cases. This is a very poor one, but the others aren't too bad. And so here is a representation of my circle for this equation. The next example we're going to have to complete some squares in order to get the correct answer. And when we do this, the first thing we're going to do is keep all of the variables on one side, and we're actually going to group the x's together and the y's together, and we're going to get rid of, or all the numbers are going to go to the right side. So my first step would be to group the x's, so I get x squared minus 12x, and I'm going to leave a little bit of room. Then I'm going to group the y's, plus y squared minus 4y plus, and leave a little bit of room. And at the same time, I'm going to subtract 40 from both sides so that this becomes negative 36 over here. Now, we need to complete the square. Now, we need to remember how to complete the square, and that is take half of this, which is 6. So half of 12 is 2, or is 6. And then we're going to square that and get 36. So we're going to put 36 here. But to keep it equal, we're going to have to come over here and add 36 to this side. Otherwise, if we just add 36 to this side, we have changed the entire problem. Likewise here, what we're going to do is we're going to take half of 4, which is 2, and then square it to get 4. So that goes 4 there, but to keep it equal, we're going to have to add 4 to this side as well. Now it's time to rewrite this, and the whole purpose of writing or completing the square is so that we can write it as a square. X minus 6, the quantity squared, plus y minus 2, the quantity squared, equals negative 36 plus 4 equals 4. And we are asked to find the center and the radius. Well, the center will be x minus 6, y minus 2. There's the center, and the radius is the square root of 4, which equals 2. Now, if we were asked to graph this, it would not be terribly difficult to do so. We would just find our center here, and then go 2 above it, 2 below it, 2 to the right, and 2 to the left. Example 6. We are asked to find the equation of the line containing the centers of the two circles. So what we're going to have to do is we're going to have to find the center of both of these circles, and then find the line that goes through them. So let's look at the first one. X squared plus y squared minus 6x minus 2y plus 9 equals 0. Group the variables together and get the other number to the other side. Half of 6 is 3. 3 squared is 9. So I need to come over here and add 9 as well. Half of 2 is 1. 1 squared is 1. So this becomes x minus 3, the quantity squared, plus y minus 1, the quantity squared, equals 1. The center would be 3, 1. Now that's just a very small part of this problem, because now we have to take the other circle, x squared plus y squared minus 10x plus 8y plus 37 equals 0. Grouping the x's together and the y's, and moving the number to the other side. Completing the square. Half of 10 is 5. 5 squared is 25. Add 25 over here as well. Half of 8 is 4. 4 squared is 16. So add 16 here. And so this becomes x minus 5, the quantity squared, plus y plus 4, the quantity squared, equals, not that this really matters, but it equals 4. And the center would then be 5, negative 4. So we know this is one center, 3, 1, and the other center is 5, negative 4. And so now we need to find the line that goes through those 2 points. in order to do that, we need to first of all find the slope. So the slope would be 1 minus a negative 4 over 3 minus 5, or 5 over negative 2, or negative 5 halves. Then we have to use one of these points, and I'm going to use this one just because the numbers are smaller, to put it into the point slope form, which is y minus the y value equals negative 5 halves, which is the slope, times x minus 3. And then it's just a matter of simplifying this problem so that we get y minus 1 equals negative 5 halves x plus 15 halves when we do the multiplication. Then I'm going to add 1 to both sides so that we get y equals negative 5 halves x plus 17 halves. And that should be the equation of the line that contains the centers. Then finally, example number 7. Example number 7 says, a power outage affected all homes and businesses within a 2-mile radius of the power station. If the power station is located 4 miles west and 1 mile north of the center of town, so if it's going west, that would be negative 4, and if it's going north, it would be 1. Find the equation of the circle consisting of the furthest points from the station affected by the power outage. So we've got our center, we've got our radius, so it's just a matter of plugging it in. So it's going to be x minus the negative 4, quantity squared, plus y minus 1, quantity squared, equals 2 squared. This becomes x plus 4, quantity squared. This remains y minus 1, the quantity squared, and 2 squared is 4, and that is the final answer.